Right, in this video we're going to go through the extended response worksheet I gave you in preparation for your test. There are 3 questions. They are, some of them a bit challenging. I think I got most of them from Year 12 Further Maths, but it is still at a Year 10 level. For your test, make sure that you just take your time and think about it. Sometimes things might not be as straightforward as they may be, and other times you need to just think, well, this isn't that complicated. Okay, so it does start off quite easy and quite straightforward, and then towards the end gets a little bit more challenging. All right, so let's move on. Jessica is walking to Emma's house, but on the way she bumps into her friend Sneedeep. The following graph shows her journey. Okay, so on this graph we can see the time in minutes, the distance. So Jessica is walking to her friend's house. Let's just see if I can make this a bit smaller so we can actually see the graph while I'm talking about it. So here she is, the distance from home. So I might just indicate there. Okay, so this is her house here. Okay, and she's walking to Sneedeep's house. And something happens here in this red part. Okay, and I think that's one of the questions. And then the pink part. Okay, so she bumps into her friend Sneedeep. The following graph shows her journey. So the question A, and I can see this here, how long did she talk to Sneedeep for? So here Jessica is walking and then she stops. Okay, she stopped here. And this straight line means time is passing. Okay, so your time is still going on, but she's not moving. So obviously we'd say she's talking to Sneedeep here. So from this point here to this point here, she is talking to Sneedeep. And we've got to think, all right, what is our scale going up to? So if this is 20, we've got to say, all right, 5, 10, 15, 20. We're going up in groups of 5. So she talks to Sneedeep from the 5th to the 15th minute. So she's talking to Sneedeep for 15 minutes. All right, so I'll just scroll down so we can, let's see, make these things very user-friendly. All right, I'll write the answer down. So how long did she talk to Sneedeep for? 10 minutes. Oh, it's a terrible one. Okay, so how far away does Emma live from Jessica's house? So we're assuming here that's Jessica's house. So with your ruler, you need to say, all right, we're going across to here. Now, it's a bit harder because I don't have a ruler and these lines are very fine, but it looks halfway between 2,500 and 3,000. So she lives 2,750 meters away. It sounds like a lot, but that is actually just, and you don't have to convert it, but it is 2.75 kilometers. Okay, so not too far. Pretty far to walk though, probably take her, well, we can see how long it took her, it took her half an hour. And that's actually question C. So how long did it take her to walk to Emma's house? So here she is here. So this point here we know is at 2750, but this is the time. So it took her 30 minutes to walk there. It doesn't matter that she talked to Sneedeep here. So all up, it took her 30 minutes. Okay, so it's quite fast walking considering she spoke to Sneedeep for 15 minutes. But anyway, let's move on. All right, D, what is her average walking speed? So this is where I think she probably didn't walk, she ran. You're not going to be tested on this, but you, oops, what did I do? Okay, so when we talk about average, we take it from one point to the end point. So this isn't going to be assessed at Year 10, but it's good to know for Year 12, if you move into Year 12, or Year 11, sorry. Now I just realised how I can draw a straight line. So I can go from this point here. No, you're going to let me go from this point? Yes, you are. There we go. Isn't that nice? Okay, so that straight line is the average. Okay, and when we do averages, we do it from the starting point to the end point, and her average speed is just distance over time. So if you remember, I guess, oh, why'd you go away? Can I do Control Z? No, sorry. Let's put you back on. Okay, so, sorry, what did I do? Oh, I'm going to pause because, all right, sorry about that. I do not know what I did. I'm sure one day I'll figure out how to actually use technology. Okay, so there's our line, and maybe in science you've done speed. Oh, you did it again. Sorry, how frustrating for you. So put the line back on. I've drawn, written this speed formula. So we're doing question D. So speed equals distance over time. And when you look at it, distance over time, that is your gradient. So the gradient of this line. So as I said before, you don't have to do this. Even in further maths, you don't do this as a part of your course. But if you did methods or specialist, you need to know this. Okay, so the gradient of this line, the difference between the 2 points, so we are starting at 0, 0, and we're going up. We worked out before was 2750, and it's over 30. Okay, so I'm just going to do that quickly on my calculator. 2750 divided by 30. So she's walking at an average speed of 91.67 meters per minute. Yeah, that's not too bad. I think that sounds pretty reasonable. All right, so let's move on. Now remember that's not on your assessment. Okay, this is so hard to use. Okay, let's move on. So the purpose of that one is to actually understand what is happening in that graph, what this straight line means. So the straight line means time is passing, okay? You can't stop time, but she's not moving. Okay, so she's staying still. She's talking to Sneedeep. Where you need to know how long it takes, okay? So being able to read the graph, and average walking speed, as I said before, not something that you're going to be assessed on in year 10. It's not a part of the further maths course, although your teachers may still teach it to you, but definitely a part of methods. Okay, so Jessica stayed at Emma's house for 30 minutes and then returned home. It was getting dark. She was worried her mum would tell her off for being late, so she ran all the way home. She ran at a speed of 200 meters a minute. So sketch Jessica's time at Emma's house on the graph. So she stayed at Emma's house for 30 minutes. So let's go back to the graph. Now we know before that if she is staying somewhere, it is a straight line graph. Now let's see if I can actually draw this straight line graph without zooming in. All right, so she got to Emma's house here at 30 minutes. So if she just stayed 30 minutes, she's at 60. So we're going from, oh, look at that. Okay, there we go. So that's her line. Now, if she's returning at a speed of 200 meters a minute, again, this is kind of stuff you need to know for methods, but still good to know now. So if she's traveling 200 meters a minute, you need to know how long it's going to take her to go home. So she needs to travel a distance of 2,750 meters to get home. So I'm just thinking, okay, so to work out how long it takes her, so we do the distance divided by the speed, so 2,750 divided by 200 is 1375. So it takes her 13 minutes, 0.75. So 0.75, when you convert that into minutes, is 45 seconds. So on your graph, and I might do this in a different color. Let's do this one in green. So she leaves her friend's house at the 60-minute mark, and it's taking her 13 minutes and 45 seconds. So we just add on 13 to there. So we're going to be around here. Oh, it didn't work too well, did it? Can I undo that? Didn't have it on a straight line. Okay, so start there. There we go. There's our line. All right. So we have this here, our green line. I don't know what the other questions are. Let's just scroll. I don't know whether my writing's going to go. No, it's not going to let me move. It's frustrating. Okay, so this is all going to go now. Just remember your endpoint. Okay. So scrolling down, write the equation that represents her journey home. Okay, so her journey home. So this is frustrating. So her journey home was from, I can quickly just draw it anyway. Yeah, to here. And what do we know about this line? So we know the gradient is negative 200. Okay, it's negative because she's traveling home, and I can actually look at the graph and see that it is negative. It told me her speed was 200, so that's the gradient, the rate of change. We can use a point on the graph. So this point here that she finished at was 60 minutes, 2750. So we just substitute that point into y equals mx plus c. All right, so y is 2750 equals m, which is negative 200, times x, which is 60, plus c. So the whole purpose of doing this is to get what C is. So you can do solve on your calculator, or you can solve by hand. I'm just going to quickly do it on my calculator. Oops. Oh, that's frustrating. 2750. Yeah, I don't know if I'm getting the right answer. Okay. Oh, sorry. Okay, so it's 1475. Oh, 0. And I can see that if I look at my graph, okay, it's going to have quite a high, if this line kept going, the y-intercept is going to be quite high. So my final equation is y equals, the gradient is negative 200 x plus 14750. I'm sorry, it's a bit hard to see that green against the grey. Technically, we should restrict what we call the domain. So it goes from 60 to, what was it, 73.75. Oh, no, sorry. 60 to 73.5. Now you don't have to do that on your test. If you do have to write the equation of a line, you don't have to restrict what we call the domain. So just because this line doesn't keep going, it starts at 60 and ends at 73.5. But that is something that if you go into methods that you need to actually understand. All right, let's move on to the next question. Actually, I might stop the video here and do another video for question 2.